Parkinson's disease, effects on the human brain. Information sourced from Davis Finney, Every Victory Counts, Parkinson's Manual. Additional sources from the National Library of Medicine and the National Institute of Aging. 3D models from Anatomography. More information on our sources provided in the notes of this video. Parkinson's disease is a degenerative and chronic disorder that affects motor functions. It causes damage to the dopamine-producing nerve cells deep inside the brain. This produces a progressively worsening effect on the body's ability to regulate speed, quality, fluency, and ease of motion. But how does this degradation occur, and what happens to the brain and body as it undergoes the stages of Parkinson's? Let's begin by taking a closer look at the human brain. The part of the brain Parkinson's targets is a tiny region called the substantia nigra. It is part of the basal ganglia and is located in the center of the brain. The basal ganglia is an area of interconnected nerve cell clusters. These nerve cells, or neurons, that make up the basal ganglia process messages that are communicated between the body and the brain. The nerve cells in the substantia nigra are the primary producers of a neurotransmitter, dopamine. Dopamine is the neurotransmitter, the chemical messenger that relays these messages between the nerve cells in the basal ganglia. Their primary responsibility is motor control, but also motor learning, executive functions and behaviors, and emotion. Dopamine-relayed information comes to the central area of the basal ganglia, called the striatum, which works with the substantia nigra to send messages back and forth from the spinal cord to the brain. Additionally, another region of the brain, the cerebellum, works with the basal ganglia to ensure that movement is carried out in a smooth and fluid manner. These messages are transferred from neuron to neuron, moving quickly from the brain to the spinal cord and finally to the muscles, causing movement. In Parkinson's disease, neurons of the substantia nigra progressively deteriorate, resulting in lower amounts of dopamine available for neurotransmission. This happens because the nerve cells in the basal ganglia fire in order to communicate with one another, but there isn't enough dopamine to transmit the messages. As Parkinson's deterioration of nerve cells progresses, the brain's ability to control movement weakens and the body becomes increasingly less mobile. By the time 80% of the dopamine-producing nerve cells are lost, Parkinson's symptoms start to become physically apparent. The 4 cardinal symptoms of Parkinson's are slowness, stiffness, resting tremor, and postural instability. Because of these primary symptoms, Parkinson's is officially classified as a movement disorder, though there are non-motor symptoms that are also associated with Parkinson's. Some of these additional non-motor symptoms are constipation, depression and anxiety, and a loss of working memory, which is often a side effect of medication. It is important to note that Parkinson's is both chronic and progressive, which means symptoms will change and worsen as time goes on. The rate of progression will vary from person to person. No 2 people living with Parkinson's will experience its symptoms or progression in the same way. The brain is extremely complex, and there is a lot of work to be done before researchers can get a full understanding of Parkinson's. However, with modern science and technology, we have been able to get a clearer picture than ever before of the intricacies of Parkinson's disease and its effects on the human brain. We hope that this program has been informative, and you now have a better understanding of Parkinson's. If you want to learn more, consider visiting the Every Victory Counts website, or check out any of the sources in our video's notes. Thank you.